Good morning and welcome to today's quick refresher on decimal numbers after we had a little bit of trouble yesterday. So the first thing I noticed yesterday is that we were having a bit of trouble ordering and sequencing decimal numbers. So if we look up here at this number line, a few students seem to do this where we go 3.7, 3.8, 3.9 and then the next number in the sequence many students believed would be 3.10, which makes sense in some ways because we're counting 7, 8, 9, 10, so I can see where you're coming from. But we have to remember that these decimal numbers are fractions of a whole number. So if we have 7 tenths, it's the same as 7 out of 10. 8 tenths, 9 tenths. When we get to 10 tenths, we have to remember that 10 tenths is a whole number. So rather than go 3 and then a whole number, extra one here, counting to 10, this becomes a whole number which moves over to this side of the decimal place. So we would actually end up with 4.0. So if we look down here, 3.7, 3.8, 3.9 goes to 4 because it's 9 tenths becomes the next one in the sequence, counting up in 1 tenth at a time, is 3 and 10 tenths, which is the same as 1. 3 plus 1 equals 4. Then when we add the next tenth on, it'll be 4 and 1 tenth, 4 and 2 tenths all the way up till we get to 4 and 9 tenths, and the next one in the sequence will of course be 5. Okay, so the next thing that we kind of struggled with a little bit was thinking that longer numbers are always going to be larger numbers, because without a decimal point, that is kind of true. When we look at numbers like these ones, for example, we know that 612, because it has less digits, is going to be smaller than 3,149, because this number has a 3 in the thousands column, meaning this number basically has a 0. 612 doesn't have any thousands, so 3,000s, regardless of what the rest of these digits are, 3,000s is going to be bigger than 0,000s in a number. When we're looking at these numbers, we know as well that the decimal place, if we were to include one, would be here, and that there would be 0 fractions of the number. These are just whole numbers, pretty straightforward. If we look down here, we've got the same digits, but here we've changed where the decimal place is. So we've put this one here, which makes this number 61.2, 6 tenths, 1 1, 2 tenths. Down here, the decimal place is closer to the front, so it's 3 ones, 1 tenth, 4 hundredths, and 9 thousandths. Meaning that this number here, even though it has less digits, becomes the bigger number because it has 6 tens, whereas this one has 0 tens. An easier way to look at this is to use one of these place value charts. Pop that there. Okay, so the number we were looking at before was 61.2. So 6 tenths, 1 1, and then 2 tenths. Whereas the second number, even though it has more digits, only has 3 ones, 1 tenth, 4 hundredths, and 9 thousandths. So this makes it a bit more straightforward. We can clearly see that this number up here, these numbers we can just count as zeros. We can pop a 0 in here, so now we see it has the same number of digits essentially, we just add in the zeros. But this one has 6 in the tens, which is a higher place value, meaning that this number is larger than this number. The last thing that we had a little bit of trouble with was confusing tenths and tens, hundredths and hundreds, and thousandths and thousands. So a few students were able to correctly identify that this number had 2 hundredths, for example, but then they could also identify down here that this number had 4 hundredths. So some people got a little bit confused and thought that the 4 hundredths would be bigger than the 2 hundreds, not realizing that those are two separate numbers, two separate digits. Numbers on the right side of the decimal place are fractions of a whole number, whereas numbers on the left side are whole numbers. All right, I hope that helps.